Hey guys, here's today's warm up. It's 3 questions. It's 3 word problems that you are going to solve that deal with rational expressions or rational numbers, so positives and negatives. My hint to you is make sure that you look for those keywords that mean add, subtract, multiply, divide, and the keywords that make you think of a positive or negative number. Remember to think about these in units because there is a word problem. If you're at home, you can type in this document that's on your jump drive, or you can take a picture and write it on lined paper and upload it to the jump drive. If you're at home with internet, you need to go ahead and go to assessments and do this warm up, then head on back here. Okay, so our goal or our what we want to accomplish by the end of this week, we're going to have the same I can for the rest of this week, is I can calculate the probability of a complex event. So yesterday we reviewed simple events, and then starting today, Wednesday and Thursday, we're going to look at complex events. And in the notes, I have a place where I'm going to write down what a compound event is. Not complex. Sorry. Compound. So we're going to try to find the probability of a compound event. So, big thing, think about the word compound and what does that mean to you? I kind of gave it away already, like I would have in class. So, I kind of already ruined the surprise like I would have in class, but a compound event, these are complex. When you think of the word complex versus simple, complex seems harder, right? Seems more in depth. There's more to it than just something that's really simple, and that's right. So with these compound events, this is more than one event. So this is when we're doing more than one thing. So this is like if we roll a dice and flip a coin. So when we were doing tree diagrams and we were doing the FCP, that had to deal with complex events. You were doing more than one thing. You were pulling out a marble and flipping a coin. You were pulling out a letter and picking a shirt. Okay? So complex probability. Well, what is that? Well, or compound probability. It's the probability of a compound event. So it's just like with single events. This is the probability that a compound event occurs. So you still do favorable over total, but finding favorable gets harder. Usually there are 2 different methods to do this. So there's 2 different ways to do this compound probability. We're going to skip the one with tree diagrams. We're just not going to do that. So here where it says use a tree diagram and list the sample space to find the probability, we're not going to do that. We're just going to focus on using FCP. So when we did FCP, it was number of outcomes times the number of outcomes for the other event, remember? We multiplied the possible outcomes together. So that was FCP. When we are doing, I'm sorry, it's wanting to be crazy. There we go. So FCP was number of outcomes times number of outcomes. Well, when we're doing FC probability using FCP, because we have 2 different events, we do probability of first event times the probability of the second event. And we're going to do plenty of examples with this, okay? So, knowing that, let's jump into the first example. Let me make that focus. So, number 1, says a standard die is rolled, then a coin is tossed. Okay, so a standard die is rolled, then a coin is tossed. So I'm going to go ahead and write out my events. So event 1, I'm going to do the dice. So we're rolling a die. Event 2, is tossing a coin. So does everyone see that? We're rolling a dice, then we're tossing a coin. Well, my options on rolling this dice are what? What kind of options could happen? What could we roll? Well, we could roll a 1, 2, 3, 4, 5, or a 6. Okay, you agree? So how many total outcomes are for rolling a dice? There's 6. Well, with my coin, what are my outcomes? Well, that's a heads or a tails. So my total number of outcomes for that coin is 2. Okay, so that's kind of building my information that I'm going to really need over here. So A says that probability of heads. Does it mention anything about the coin? It doesn't. So that means it's okay with any of the options on the coin. Okay. It's okay with any of the options on the dice, not the coin, I'm sorry, the dice. So it doesn't mention anything about the dice, so it's okay if you roll 1, 2, 3, 4, 5, or 6. All of those are okay. So how many favorable outcomes are there if you're okay with all of them? Well, there'd be 6. If you're okay with any of them, you would have a 6 out of 6 chance for that. Then it says it wants a heads. What's the probability of flipping heads on a coin? Well, there's 1 favorable outcome out of the 2 total. So flipping heads is a 1 out of 2. Remember, I said probability using FCP of these complex or compound events. You multiply the probabilities together. So we have to do 6 over 6 times 1/2. 6 times 1, 6. 6 times 2 is 12. Well, what is that simplified? Because I can divide both of those by 6. It's a 1/2 chance. Okay. Now look at B. It says probability of an even number. So that means when we roll that dice, we want an even number. Well, how many of them are even out of our total outcomes? Well, 2 is even, 4 is even, and 6 is even. So there are 1, 2, 3 favorables out of a total of 6. Here's a little hint, you don't have to simplify these until after you multiply. Then, does it say anything about the coin? Does it say anything about the coin? No. So we're happy if we get heads or tails. So since we are fine with either one of those, there are 2 favorables out of 2 total outcomes. And then we just multiply them. So 3 times 2 is 6. 6 times 2 is 12. Then we can divide both of those by 6, and you get a 1/2 chance. Okay, look at C. Oh, look, we're getting into these harder questions. It says we want an odd number, and then we want tails. So let's look at the odd number first. So we want probability of an odd number. Well, what would make that happy if we want an odd number? Well, we would be happy if we rolled a 1, a 3, or a 6. So a 1, 3, or 6. That's 3 different options because 1, 2, 3 out of 6 total. Then we want tails. Well, what's the probability of flipping tails? Well, there's 1 favorable out of 2. There's a 1 out of 2 chance of flipping tails. Then we multiply them together. 3 times 1 is 3, and 6 times 2 is 12. Both of those can be divided by 3, and you get 1/4. So there's a 1/4 chance of rolling an odd number and then flipping tails. So look at D, and I want you to try it. So pause and try and come back. Okay. So hold on. Excuse me. So probability of at least 5. So that's like you look at mom, you say, I need at least $5. So think about what would make you happy if you need at least 5. Well, you'd be happy with 5 and 6. So you need 5 or more. So there's 5 and 6. So there's 2 favorable out of the 6 sides on the dice. So at least 5 is a 2 out of 6 chance. Then heads. Well, there's a 1 out of 2 chance that you can get heads. What I do then is we multiply straight across. So 2 times 1 is 2. 6 times 2 is 12. Both of those can be divided by 2, and we get a 1/6 chance. Okay. What you're going to do now is this one. How is that different? How is that different? It's got that or, doesn't it? Doesn't it have the or? Well, you're in luck because we're not going to do or right now. We're going to come back to that this week. So we're not going to do this one because of that sneaky little or. Or sneaky. We will come back to or statements later this week. I don't want to overwhelm. So I'm going to go ahead and I'm going to pull your homework over here. I'll be right back. Okay, so here is your homework, and all you're going to do today is you're going to tell me what event 1 is and what event 2 is. You're not going to be finding actual probabilities yet. We're going to get into that with some more practice. So you will be, if you're on assessment, you'll type in like a essay question what event 1 and event 2 are. If you're at home, you can either type on the document and resave it, or you can write it down on a piece of paper and take a picture of it and save it to your Jump Drive. Again, if you need help, you need to reach out to me before clicking that show answer button. Okay, have a great night, guys.